I'm going to put in a thermocouple for exhaust gas temperature, and these are some of the things you can use to do it in a very basic DIY manner. This is usually used in max effort engines, and you put one thermocouple per cylinder, and then you can look at the temperatures and determine whether or not a cylinder is getting more or less airflow, fuel, and you can adjust ignition and things like that in really high performance engines. But it's cool because you can also take this for fairly inexpensive and apply it to any car. Anything that has exhaust that you can measure the temperature of, turbocharged or non-turbocharged. In this case, my car is turbocharged, and I'm only going to use one, which isn't very accurate because we've got individual cylinders, but it will give me a general idea of what the exhaust gas temperatures look like right before the turbine. You can even put it after the turbine to see how much temperature drop there is across the turbine on a turbo. There's lots of cool things you can do with that. My purpose is I have a fairly high back pressure on a turbo for my car, and I want to see how that affects exhaust gas temperatures before I change the turbo to something a little more suited for that size of motor, a little more free flow, and I'm just curious if it drops the EGTs. So that's what we're going to find out today, but you can do this as well on your own car. Let's jump right into it. The things you will need are a thermocouple, a way to interface with the manifold and the thermocouple. Usually there are specific fittings that are compression made specifically to take a thermocouple and go into a manifold threaded. In this case, I've just used a standard compression fitting. It won't be on the car very long, and it doesn't matter if it's brass at this time because it's, I'm not worried about racing it or anything. The temperatures aren't going to be crazy for very long. It'll be putting it in the car and removing it after I get a little bit of data, a few data logs, and it won't be an issue to have a brass fitting in the exhaust. Brass can handle quite a bit, but usually you'd use stainless steel on this. I just happened to find one of these at the local hardware store for a couple bucks, so it's not really a big deal. The next thing you need is a thermocouple. Thermocouples come in a lot of different standards, and the one that is used the most for vehicles and kind of higher temperature is Type K. Type K goes from around 32 degrees, so like freezing, up to, this one is 2100 degrees Fahrenheit, so it can handle a lot. And there are a variety of thermocouples that are Type K, so you can get a Type K thermocouple that only goes up to like 700, 900, 1100 degrees Fahrenheit. So you have to be careful of what you buy. It's usually the material that it's made out of. This one is made out of Inconel 600, so it is really capable of taking some heat without being damaged. Automation Direct is where I got this one, and there's your part number. This isn't ideal. It's a little bit big. This is a 1/4 inch shaft diameter, and it's 6 inches long. But it was fairly inexpensive, and it will definitely do the job, and I can use it in a few different applications. So that's the thermocouple we're going to use. It has like a 6-foot lead on it, so we have plenty of cable. It's steel, stainless steel braided, so it can handle some abrasion or being in the working environment of an engine bay. And that one, it'll suit us just well for what we're going to do. The next thing you need for the thermocouple is an amplifier. The voltage output from a thermocouple is very, very small, and it has to be amplified up to something that an ECU or an Arduino can read. So you have to buy one of these. This is a thermocouple amplifier. This one is by Adafruit. It is called a Max, if I can get it here, it's called a Max 31855. This one is used to direct with SPI or interface with SPI. You use a bunch of these pins to connect via SPI on like a industrial controller or an Arduino. In this case, I have both an analog and an SPI. You could, if you wanted to go to an Arduino and you didn't have an aftermarket standalone ECU, you could definitely use this and or the analog version and go into an Arduino and then log it on an Arduino. But I have chosen to go with the analog version of this because I have a Megasquirt. So let me flip this around. Yeah, so this one is an Adafruit 8495. Type K thermocouple amplifier. It gives you an equation here at the bottom to convert it to Celsius. And I have made a chart that converts all the temperature range in Celsius that I can put into the Megasquirt and use that to give me an output from the 0 to 5 volts that this is going to create. So sorry if I'm not very clear. This just has a standard, let me see if I can get to it with it focusing. It has a standard 5 volt reference on the right, ground in the middle, and then up on top you can see it says out. There we go. There's the output. So this basically takes the output voltage from the thermocouple, which is very small, amplifies it up to 0 to 5 volts, and then we interface on the Megasquirt ECU with just a 5 volt reference, a ground, and then the sensor out. So very similar to every standard 0 to 5 volt sensor you'd see, like a pressure sensor or something like that you would hook into a Megasquirt. So in this case, I won't be using it for very long, and having it not in an enclosure or a box or anything won't be a big deal. We're just going to make sure that this doesn't touch anything. None of the board touches anything. We can wrap it up wherever we're going to put it, and then these are just going to get temporarily connected to the Megasquirt until we can get some data. The next thing is these fittings. One important note real quick, if you buy the actual compression fittings that are designed for thermocouples, they are big enough inside to fit the thermocouple all the way through. But if you buy the kind from the hardware store that are meant for plumbing, they don't fit. So basically when you take this thermocouple and you try to put it through, it only goes in just a little bit. It goes into like right here, and then it hits a part where it was machined down in there where it's a lip. So the way you can get by this just for a DIY inexpensive way is just drill this out. Just get a 1/4 inch drill bit and drill that out. You might have to wallow it just a little bit bigger than a 1/4 inch so it'll slide. But the part that I have previously installed on the car is actually been drilled out, and this should fit through just fine. And then the normal 1/4 inch compression fittings will fit on the end of this just fine. You can see right here, it goes through, and then you can fit the ferrule right on there. Okay, so basically this is going through. It'll stick through inside the exhaust manifold, and it will allow the tip of this where the sensor is to receive the heat from the exhaust. Last time I installed a back pressure sensor with the same brass fitting just barely shown, and just loosely put it in here because it was temporary. We were just going to get some data, take a few polls on the highway and get some data and then remove it. So that's my first step right now, is just to get this sensor out of the way, and then we're going to start installing the new thermocouple. So we just need to now determine how far in this thing's going to go. Past the fitting, we want it to be about 3/4 of an inch into the pipe on a turbo, like 1 inch to 3/4. Let's see, somewhere in there. So now all I'm going to do is mark the end of the pipe, so when I put the fitting on, I know roughly how far this is going to be in the manifold. So we'll just go right here, take a Sharpie and mark it roughly right there. Okay, that'll be the first thing we do, and then we'll drop this guy in. Okay, so the next step is pretty much there. you can see, I don't know if you can see my mark right there on the bottom. I got it lined up, tightened it down just a little bit. These compression nuts, they don't need very much. Usually like 3/4 of a turn is like plenty on them, just enough so that that brass washer crushes against the sleeving and creates a seal. So as long as it doesn't pull out and it's got a good seal, that's really all it needs. But it worked out okay. Yeah, you can just see in there. You can bend these. Only the first like 1.5 inches is crucial to where the sensor is. The rest of it you could put a radius on, but it fits like dead on, just kind of down in there for this application. So I'm just gonna leave it and then run it over to this this area in here with the wire, and we should be good. Should be able to get a test. For temporary use, I'm just using a block connector. You can plug it into stuff. It's like a Phoenix connector. You can plug it into the back of a piece of equipment, but it also works really well as just a clamp to connect two things together. Like I said, this is very temporary. I'm only going to use this until I get some data, go run it around, get a couple data logs, and then this will be removed. So the wiring portion, I'm just going to wrap this up and zip tie it so it's out of the way, and it will only be used temporarily. So we have the 5-volt ground and out going to the 5-volt VREF on the Megasquirt, and then the ground, which is a sensor ground, and then this is actually the MAF. So you can see on the Megasquirt wiring, if it will focus, it says MAF right there. So it's the pink and black on a microsquirt, but yeah, there it is. That's the wiring thus far. Just have the thermocouple going into the amplifier and the 3 outs, the power and the 1 out. So, and it's in right there. This is the nice and clean part that actually looks good, and then it comes over to this mess which I just zip tied up. But once again, it's temporary. All we're trying to do is get a little bit of data. If I was wiring in this in the car permanently, I would do a very clean job and run this all the way inside the car, and it would be completely out of the way. But for now, we're just getting some data on a data log. So the first thing we're going to do is we're going to go up to custom channel editor. We're actually going to add a custom channel first, and we're going to call this, the input channel is going to be ADC 6 or 7. Let me see. ADC 6. We're going to call it EGT. Units are going to be in C for Celsius, linear, and the input voltage is going to be 1.4. Let me see, I made a table with the conversions for this particular amplifier from Adafruit and the thermocouple. So at 1.4 volts, the output is going to be 30 degrees Celsius, and at 5 volts, it's 750. And this is in Celsius, so it's going to be a really good range for an exhaust gas temperature sensor. Probably not going to be wanting to run it over 750 anyway. All right, so let's go next. Add a gauge template. So let's go EGT, gauge title, EGT, units, C. It's going to be actually a sensor input, and we'll just call it, it's from the channel we just created, it's EGT. So minimum 30, maximum 750, low critical, this doesn't really matter much either, but we'll go low, low critical, we'll do like 300 or less. I don't know. Low warning, 100. High warning, I don't know, 650. And then high critical, 700. Decimal places, let's give it 1. And then we definitely want to data log this. Let's call it EGT. this just makes a field in the data log so that you have EGT. Definitely want to give it at least 1 decimal place so it can be a little bit fine. And there we go, EGT. So it's as simple as that. The biggest thing is you just need to know how to set up the channels. It's a little bit confusing unless you've done it before, but basically I used the same channel last time for the back pressure sensor. So if we go in here, we can check it and see what the sensor data field was. Hold on 1 second real quick. Actually, that's EGT. Where did it go? Okay, well, it has actually changed the field to EGT because I used the same sensor channel. So basically every pin has an assigned channel, and that's like when you go to your inputs and outputs. And the channel that I chose was ADC6, so it's MAF on this microsquirt. Alright, so I set up the gauge just a second ago. I actually set, let me show you this. This is a good thing that can trip you up. If you go to Custom Channel Editor, you can see the channels you made, and last time I made back pressure, and I used ADC7, and on EGT I set it to ADC6. So I just had to go change that, because I just removed the sensor from the same wire, which correlates to the same input channel. So I just needed to change this to 7. I had forgot that it was 7. So anyway, that's that. Input voltage on the EGTs. Let's see. Let's go back here. And I just set up the gauge. I just went to sensor inputs, set it to EGT, and it made that gauge into the EGT. Because I'd set up all the values back in here in the gauge template. If you go to EGT, we had set up all those values. So that channel now is associated with those values, and when you set a gauge to that, it has the right input voltage, the right output, and you can just set whatever gauge. Like if I wanted to, I could go in and set this gauge to VE trim, or go back to like sensor inputs, which would be EGT like this. Okay, so it looks like we're at 18 degrees Celsius, which for outside right now seems just about right. So, alright, so the EGT is installed. It's kind of hovering around 14 degrees centigrade. It's on the verge of where the limit is for the sensor, so let's fire it up and see what it does. It's coming up to temp. Looking really good. Nice. There we go, it's looking pretty accurate. So we're in the car, got it nice and warmed up. You can just watch the EGTs here. I'm going to go into data logging and start logging. It's going to ask me what I want to call it. Let's call it EGT. And hit save. Okay, so you can see on the bottom, we're starting to data log. We're just going to go give it a little bit of gas. See what we can do. Small opportunity to give it some gas, so hang on. Oh, there we go. So she got hot for for sure. Oh, man, it sounds so good. It never gets old. Boost just doesn't get old. The installation went good. Doesn't look like it leaked anywhere. No black soot marks. It sounded like there wasn't any sort of leak. This thing's nice and sturdy in there. The zip tie held. Now we can just take all this, pull it out until I switch to a bigger turbocharger. Then throw that guy back in and see what kind of difference it made in EGTs and back pressure. I hope you guys learned something. This is something I've wanted to do for a really long time and was really hesitant to do, but it is super easy, and if you want to do it inexpensively and just to get a little bit of data, and it's not a serious crazy race car for you, or even if it is, you can take this and apply it with some better materials, better wiring, and things like that. Things that I don't need just because this is like a burnout car, basically just messing around with and having fun. So thanks guys, take care.